All right, so I'm just going to run through the examples in your book on manipulating formulas or rearranging formulas. So example 1 down here, make A the subject of each of the following equations. So I'll probably run through the first couple, that'll be straightforward enough. So example 1, 4A is equal to n. If I want to make A the subject, I want A on its own, so let's divide both sides by 4 to get rid of the 4 here. So A is equal to n divided by 4, and that's you done. Okay, so A is now the subject. You have A on its own, so A is equal to n over 4. Part 2 then, MA is equal to n, so I want to make A the subject. So it's move the multiplied by m, or get rid of the multiplied by m. So divide both sides by m. A is equal to n divided by m, and you're done. Okay, so A is now the subject of the formula. Part 3 then. So A over 2 is equal to P. So I want A to be the subject, so I don't want A over 2 to be the subject, so I need to get rid of the over 2, the divided by 2. So if I move a divided by 2 over the other side of an equal sign, it becomes multiplied by 2. So A is equal to 2P. Okay, or else multiply both sides by 2 and I get A is equal to 2P. The fourth part then, A over m is equal to P. So I want A to be the subject, so move the over m, move the divided by m, and you get A is equal to MP. Okay, and that's example 1 done. All right, I'll move on then to example 2 here. So make x the subject, so I've got x plus m is equal to p. So if I want x to be the subject, I move the plus m over and it becomes minus m. So x is equal to p minus m, and I'm done. Okay, x is now the subject. So move the plus m over, becomes minus, or else subtract m from both sides. That gets rid of from the left hand side and gives me a minus m on the right hand side. All right, and that's you done. Part 2 then, x minus h is equal to k. So if you move a minus h over, it becomes plus h. So x is equal to k plus h. X is now the subject, so you're done. Okay, again, just to kind of refresh, you could ask this question, instead of make x the subject, write x in terms of p and m. You could ask this one as write x in terms of h and k. Order here doesn't matter. H plus k will be fine as well. Example 3 then. Make A the subject of this formula. So V is equal to U plus AT. So I want A to be on its own if I want A to be the subject. So let's move U first. All right, so that's a goal is to get A on its own. So let's get rid of anything that isn't an A from the right hand side. So the U will be the first one to go. Okay, so get rid of this before you try to get rid of the T. So if you bring U over, it becomes minus U. So V minus U is equal to AT. I want A on its own. So you're gonna get rid of this multiplied by T. So if you divide both sides by T, you'd get rid of the t on the right hand side. So v minus u divided by t is equal to a. So I brought the multiplied by t over and it becomes divided by. Don't forget it's over the entire left hand side. So when you divide both sides by t, the entire left hand side you divide by t. So a bit awkwardly written, but v minus u over t is equal to a. And that's example 3. Done. Okay, so they're straightforward enough. They're like ones that I did on the other video. So some of the remaining ones might get a little bit trickier. So example 4 here, I'm just going to test our algebra a little bit more maybe. So make k the subject of this formula. So akb minus 2ck is equal to 7mn. So I want k to be the subject of that formula. What's the complication here? Well, it's that I've got two k's. All right, I've got a k in this term, and I've got a k in this term. And I want to write k equals something. So the fact that I've got two of them gives me a problem, okay? So how can I extract 1k from this? Okay, so rewrite this so I've just got 1k instead of 2k's. Well, what can I do in algebra when I've got a common letter in two terms? So I've got some letter in two different terms. What am I able to do? I'm able to factorize. So I've got a k here and a k here. So I'm able to factorize k out. So it's a common factor of both. So if I get k brackets, akb divided by k is just ab minus 2ck divided by k is just 2c is equal to 7mn. So by factorizing the k out of those two terms, I now just have 1k in my expression. So this is going to help me just write k equals something. Okay, so the left hand side here, I've just changed what it looks like. It's still the same thing. If I multiply this out again, k by ab is akb, k by minus c is 2ck. So all I'm doing is changing the form of it. Now I've got k multiplied by everything in this bracket. So if you move that entire bracket over, it becomes divided by. So k is equal to 7mn divided by ab minus 2c, and that's you done. Okay, you can leave that in brackets if you want, but that's k is now the subject, or k written in terms of a, b, c, m, and n. Okay, so that's why they tend to write it as make k the subject. It's a lot snappier to write than write k in terms of a, b, c, m, and n. All right, so that's it done. So if you're ever asked to do something like that, to make k the subject, and there is more than one k in the question, the method is going to be factorizing to just get 1k on the left hand side or right hand side, wherever it is. All right, example 5 then. Make p the subject of this formula here. So I've got, if they're fractions like this, it might be easier for you to split it over two lines. It might make the kind of layout and presentation a bit better. So a is equal to p minus s over t, and I want p to be the subject, so I want to get p on its own. So first thing to move here is the divided by t. Okay, I want to get p on its own, all right, but it's not the minus s that you move first. Just generally whenever you get a fraction like this, just like in the last example I would have done in the first video, you want to move the denominator in the fraction first. Okay, so move the divided by t first, because that entire side is divided by t. So kind of the p minus s is trapped up there until you get rid of the over t. Okay, so I'm going to move the over t, or the divided by t, over, and it becomes multiplied by. So a multiplied by t is equal to p minus s. And now I want p on its own, so move the minus s over, and it becomes plus s. So at plus s is equal to p, and that's you done. That's your answer. P is now the subject of that formula. All right. It doesn't have, so it's on the right hand side there. That's fine. Okay, we're probably more used to seeing P is equal to AT plus C, our kind of subject on the left-hand side, but it really doesn't matter. Okay, so AT is plus S is equal to P, and that's example 5 done. Example 6 here then. So that's another one with fractions. So S is equal to U plus V over 2 all multiplied by T. This looks like one way. We might have a couple of different ways to answer it. So make V the subject. So get V on its own. So at the moment, entire bracket here is multiplied by T. So let's get rid of that. Okay, let's move the T over. You could here, if you want, as a first move, multiply the T in. So fraction multiplied by a whole number. So TU plus T, you multiply by the top. So TU plus TV over 2 if you multiplied the T in. I don't think that helps me because I want to get V on its own. So if you multiplied the T in, you'd be going from having V on your own to having TV or VT. So I think first thing to do here is get rid of the T. So at the moment it is multiplied by T. So when I move it over, it will become divided by T. So S divided by T is equal to U plus V over 2. All right, you can keep the bracket there if you want, but with the T on, you don't really need it. So S over T is equal to U plus V over 2. So it is the V I want to get on its own. So remember, it's the 2 here you need to move first. Okay, you can't really just pluck the U over. You can, but the kind of algebra of it is a little bit tricky, and something people will be inclined to get wrong. So move the 2 over. Okay, so this is divided by 2. When you move it over the equal sign, it becomes multiplied by 2. Whether you're the way to think about it is multiply both sides by 2 to get rid of the fraction on the right hand side. So left hand side multiplied by 2. It's going to look like that. Right hand side, if you multiply that by 2, the multiplied by 2 and divided by 2 here cancel, and you're just left with U plus V. That's why we're doing it, is to get rid of the over 2. So what am I trying to do? I'm trying to get V. Yeah, so it is just a matter now of moving U over. What I would do first though is just multiply this left hand side out. So this doesn't look great at the moment. So let's just multiply the 2 in here. So again, if you are multiplying a fraction by a whole number like this, it is the top of the fraction, okay, the numerator that you multiply by the whole number. So you multiply the 2 into the top. So 2S over T is equal to U plus V. And now I want to get V on its own. So let's move U over. It's plus U here. So when you move it over, it becomes minus U. So you've got 2S over T minus U is equal to V. And that's U done. Okay, so again, doesn't matter if the V is on the right hand side. There it is in the book. The book rewrite it with the V on the left hand side. You can do that if you want, but this or this perfectly acceptable as an answer. All right, so that is example 6. Let's run through example 7. Oh, 2 more, example 7 and 8. So I'll just do 7 part 1 then. Here. So make B the subject of this formula. So I've got square root of A plus 4B is equal to 5C. So I want B to be the subject of this formula. So I want to get B on its own. So a little bit how I talked about the P up here maybe being trapped when it was all divided by T, and you want to get rid of the divided by T first before you can start doing a little bit with the P and the S, okay? It's the same thing here, okay? So the A and the B are like trapped under this square root symbol. So I can't move the A here. I can't really move the 4 here as long as they're under a square root symbol. So I want to get rid of that square root symbol. What's the opposite of square root? it's squaring. So what you're going to do is square the left-hand side, because that will just get rid of the square root sign. If you square the left-hand side, what do you need to do to the right-hand side? The exact same thing. You need to square it. All right. So left-hand side now, as I said, the square root symbol and the squared, they just cancel. So that's why we're squaring, is just to get rid of that symbol. So you are now just left with a plus 4b equals 5c squared. So this is one of my rules of indices, that when you're squaring something out like this, so let's say here ab to the power of p is equal to a to the power of p, b to the power of p. So you raise both things to the power. All right. So what does that mean here? It means this is equal to 5 squared c squared. So you square both terms. So this is 5 multiplied by c. So when you square that out, it will be 5 squared is 25, and also c squared. Now, we want to get b on its own. So if you've got a plus 4b, first thing to move is the a. So move the a over, it becomes minus a. So 4b is equal to 25 c squared minus a, and then it's b on its own. So you want to get rid of this multiplied by 4. So if you divide both sides by 4 to get rid of that, divide the left hand side by 4, you're just left with b. Divide the right hand side by 4 then, and you're going to end up with the entire right hand side over 4. Okay, again, we can talk about that as moving the multiplied by 4 over and it becoming divided, but that's what you should end up with. Okay, so if you see a square root symbol in one of these questions, you're going to be squaring to get rid of it, square the other side as well, and then it will just be like the other questions. You're kind of moving around, you're adding, you're subtracting, you're multiplying, dividing, just doing the opposite to what was being done. All right, so 7 part 2 then, so nearly kind of mirror image of that question. So make or the subject of that formula. So you have got volume, or you got v is equal to pi or squared. That's not a volume formula. So v is equal to pi or squared. So I don't know why they wouldn't say a, because that's the area formula anyway. V is equal to pi or squared. We want to get or on its own. So first thing to do is get rid of that multiplied by pi. So move it over, it becomes divided by pi. So volume divided by pi is equal to or squared. All right, so dividing both sides by pi, or moving the pi over and dividing. So v over pi is equal to or squared. I don't want or squared to be the subject. I want or to be the subject of the formula. So how do I get rid of a squared? Well, if I get something like or squared is equal to 7, how do I solve it? I use square root. Okay, so I would get the square root of 7, and or is equal to the square root of 7. So the opposite of squaring is square root, and it's the same principle here. All right, so you're just going to get the square root of both sides. So left hand side is the square root of v over pi, and the square root of or squared is just or. The square root and the square cancel each other out. You can write that out in 2 steps if you want. Okay, but that's that one. All right, so if you get square root in your question, you'll be squaring to get rid of it. If what you want as the subject is squared, then in your final step you will be using square root to get rid of the squared, and that's 7-2 done. So last one then is example 8 here, which is make L the subject of this formula here. So t is equal to 2 pi square root L over G. So, and let's make L the subject of this formula. So I want L on its own. So you can square both sides straight away to get rid of the square root. You'd end up with t squared equals, you'd square this, you'd get 4 pi squared, and you'd get rid of that square root symbol. I think the easier thing to do here though might be move the 2 pi first. Okay, so get the kind of square root on its own first and then do your squaring. So move the multiplied by 2 pi over and it becomes divided by 2 pi. So this is 2 pi multiplied by that square root. So bring it over and you're going to have t over 2 pi is equal to the square root of L over G. I want to get L on its own, so I need to get rid of this square root symbol. I can't move the divided by G out for now because it's kind of trapped under this square root. So let's get rid of that square root by squaring the right hand side. I'll have to square the left hand side then as well. So again, rule of indices, a over b to the power of p is a to the power of p over b to the power of p. So if you're raising a fraction to some power, you raise the top and bottom to that power. So in this one here, I need to square the top and the bottom. So t squared over, don't forget 2 pi squared, you square both things. So 2 squared is 4, pi squared is just pi squared, is equal to square root and square cancel each other out, so I'm just left with L over G. So I want L on its own, so move the divided by G over and it becomes multiplied by G. And I'll do this in 2 steps. So you're going to move it over and it becomes multiplied by, or else multiply both sides by G to get rid of the G on the right hand side. So G on t squared over 4 pi squared is equal to L. To be honest, I'd say you're done there. You've kind of done what they've asked. You've made L the subject. L is on its own. But just tidying it up here, the left-hand side, you've got this bracket multiplied by G. So let's multiply the G in. The G there is a whole number. So if you multiply a whole number by a fraction, it's the top. So you're going to get GT squared. Or else you can write it as T squared. G is the same thing. Over, you don't multiply by a bottom, so you've just got 4 pi squared on the bottom is equal to L, and that's you done. Okay, you see they kind of leave it, yeah, they leave it like that. They don't multiply it in, they don't square the fraction there either. So I would say this is probably slightly better in terms of tidying up the algebra, but they're leaving it like that, so I'd say that's fine as well. Just very quickly here, I will just do what if I at this point here, so this is done, what if instead in the first step here I decided to get rid of the square root symbol and just squared both sides. So left hand side is just t squared. If you square that right hand side out, when you're squaring things that are multiplied like this, you'd end up with 4 pi squared multiplied by the squared and the square root cancel each other then, and you've got L over G. Okay, and then just move the 4 pi squared over, move the G over, and you'll end up with the same answer. But just if you did do the squaring first, that's what you'd end up with. All I would say, when people try and square something like that on the right hand side, they tend to trip them up. Okay, so just you square both things separately. So the 4 pi squared, get rid of the square root there. They're multiplied by here, so they're still multiplied by after you square them. And as I said, from there you'd be kind of jumping into around about this step here and solving it the same way. But I would say the way I did it is probably the more straightforward way and the way people will find easier. All right, so that's the 8 examples in the book, done covering pretty much most of what could come up in one of these questions. So again, don't forget, it's back to principles from solving equations, and a lot of these, if you were trying to solve equations using these techniques, you'd be able to do them. So don't be thrown off by the fact that there's more letters than usual and you're not actually ending up solving them. The principle is the same. You want a letter on its own. Okay, do the same thing to both sides of an equation, or if you move something over an equal sign, you do the opposite with it.